Yay, lifetime, says DIY. Oh, too loud, too loud. Turning it down. Good morning, everybody. Oh, I'm literally sweating because I've been rushing around. I've just been cleaning up out in the loading dock area and vacuuming and stacking things and moving stuff, getting things ready so that there's a little bit of room for the barbecue. There's, once the live stream finishes, there's not much of a gap between that and people arriving, so I don't really have time to prepare afterwards. I have to prepare beforehand. What am I doing? Okay. First up, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, I need to pause for a bit of a breath. So David was talking about, what, 1.27 millimeter headers. Was it 1.27 or 2 millimeter that I specified on the ESP flash? Let's see, I can't remember, I'm just looking it up. Where is this? Where did I do this? Right about here. ESP flash. I can't even remember which size. Oh yes, here we go. 1.27 millimeter pitch. So 2 by 3, so it's a 6-pin connector, like that, in 1.27 millimeter pitch. Yeah, they're a bit of a pain to solder, aren't they? And it's annoying, like 1.27 millimeter pitch isn't too bad if you're dealing with surface mount stuff, but when you're dealing with through hole, because you need enough room for the pin, the hole to be drilled, then you need the annular ring around it, you end up with very small clearances in between the pads. So yeah, 1.27 millimeter on through hole is pretty tight. It's not a whole lot of fun. 2 millimeter is such an oddball to source. Henrik, yes, it is your stuff again. I have, let's see, is it there? There is the box of Henrik stuff. I don't think I focused the camera. That was one thing that I forgot to do before the stream started. John says, good morning, sorry I'm late. No, you are not late. I am only just getting started now. So good morning to Keith H. Mr. Barbecue himself is here. Dodgy's here. James. Amanda's here. Amanda said, good morning from my home in Toronto, New South Wales. Yes, now out of the hospital. Yeah, I'm really glad to hear that. So, yes, I heard that you were in hospital during the week. I'm glad that you're on the mend. That's really good to hear. And Chip is here, of course. He's not actually physically here right now, but he will be a little bit later. So if you're coming to the barbecue, Chip will be here. When I say Chip, I mean outside the box. I should just call you OTB or something. Jordan, yes, thanks for coming along. Stephen is here. Someone who made, those are horrible. That is, I'm really tempted to pull that up. Has anyone here tried to create a footprint or route a footprint for the through-hole version of a USB-C header with all the pins, like not one of the abbreviated pin versions, but a full pin version? It is absolutely terrible. They're nasty, nasty things to work with. What can I open and stick one in? I actually used them on a few projects early on. So Henrik, yes, we will get to your stuff, but it won't be exclusively about your stuff today. There will be a few other random things as well. Let's find a project. No, not there. Projects. I'm just looking for some stuff. Etherbear. Etherbear I haven't looked at for a very long time. Where are we? AXA Wi-Fi. It doesn't matter. It really does not matter which board I open. AXA Wi-Fi. Yeah, what the hell. Let's open the AXA Wi-Fi board just because I can. And go to here. I had someone contact me during the week saying they wanted to buy 5 of these, and I'm kind of tempted to finish this off. Like, this board works. I've just never really put it into production. Mechanically, it's got a couple of clearance issues. There's a whole backstory to this that I won't get into right now, because the whole point of this, where is the schematic? Let's bring the schematic up here. yoink, and let's add, get out of select mode, let's add a part. What are we going to add? We're going to add superhouse connectors. Where's USB-C? That one is the one, this is the footprint that I currently use. This is my preferred USB-C horizontal footprint. This one, oh, there's a vertical one as well. There's a vertical USB-C connector. Here's a horizontal USB-C connector. Look at this atrocity. I'm just going to dump it down there in the schematic. And then we're going to switch back to the board. Let's grab the move tool, stick it up. Where are we going to stick it? We need a bit of board to stick it on. But look at this. The particular design rules for this board, however this project was set up, it's not a tight board. Like, there's plenty of space around this. It's all big connectors and things. So the design rules on this are quite, what way around would you put it? They basically specify large clearances, large minimum annular rings and those sorts of things. And the annular rings on the USB-C connector actually overlap each other. So where are we? Tools, where are the... I hardly ever change these design rules. So if we have a look in annular ring pads, top, bottom, let's go for 6mm. Oh, the rest of these don't really matter, do they? Max 20mm, that'll do. Let's see if that changes it. Okay, so if we go for a 6mm annular ring as the minimum size, you can see that we still fail the clearance tests. So in this case, the hole and the annular ring are not touching, but they are so close that this could potentially break the production rules for some PCB houses. And yeah, the very first time that, in fact, I wasn't running with the rings that size. I think I might have gone to, what did I go for? Maybe I was using like 4mm. Let's just try that. 4mm annular rings. And when I say mil, I mean thousandths of an inch. That's not millimeters. This is furlongs sort of stuff. So this is a 4mm annular ring, so 4,000ths of a millimeter, and it still breaks the design rules for clearance on this. So if you've got a design house that does like a 6.6 design rule, the very first time I sent off a board with one of these connectors on it, it was questioned by the design house. They said, are you sure this is correct? This was actually in the fairly early days of USB-C. There weren't a whole lot of devices out there with USB-C connectors on them, and I thought I would try it on a project. And the board house, yeah, didn't like it at all. And I sent them, like, they sent me a support thing saying, are you sure that you want us to fabricate this because this is not within spec? And I said, yes, go for it. Just try it. If there are shorts between the pads, oh well, it was worth the experiment. So they fabricated it and it worked, but it was horrible to assemble just because those pins are so close together. So who was it that was complaining about USB-C? Somebody back in the chat. I've missed it now. Yeah. Yeah, the through-hole USB-C. And for reference, let's just for reference of scale, because it's very hard to tell when you're looking at stuff on screen like this. Those parts there, those other parts, are 0603 resistors. And if you've seen an 0603 resistor, you know how small it is. So that, well, that's an 0603 LED. And you can see in the length of the LED, there would be at least 3, possibly 4 through-hole pins in that length, which is ridiculous, totally ridiculous. But that's the way it is. That's the way it is. Now, the, the chat has scrolled way off the screen. Where am I? I am so far behind. Okay. Oh, Jordan said, wish we could make it for a barbecue, but it's a bit too far. Yeah, it's sad that we are constrained by the limits of geography. It'd be nice to be able to teleport around and visit people. I really want to get out. I haven't traveled for a while. I really want to get out to a few different places, see people in other parts of the world. That would be so nice, because we've been in a conference drought for a few years. We've been in a travel drought for a few years. Yes, I would like to get back out. I'd like to go back to China again. There is a trip being organised for late this year, which I would really like to go on, but I'm not sure if it's going to be possible. And I'd like, someone I know through Jiu-Jitsu has just been to Japan and just came back a couple of days ago. And so my friend Andy loves Japan as well, says that's great. So Japan is definitely on the list of places I'd like to go. And I'd also like to go back to Europe. There are so many places. I'd love to go back to Estonia. And yeah, there are many other places around that region that I would like to see. So where are we? Where are we? Okay. Oh, John says, good morning. I think I said hello to you earlier. Paul Gray is here. Oh, Imi is here. Justin C. Simon. David. Any Mules is here. Luminator. Scott. Yeah, Scott says, all USB-C jacks are nasty in some way or another. Stephen W says, I did a vertical one. It requires many layers as you also have to dodge the 4 mechanical pins. Oh, right, yes. Dodging the mechanical pins is bad as well. So you can see in this particular case, that's the other thing, is that this one has locating stakes. Now, where is the origin for this? Right here. I'm going to stick this one here, and then let's add another part. Superhouse connectors, USB-C, we'll go for the vertical one. Okay, so this is kind of getting me onto the where am I? Is that the right thing? Am I looking at the right place? Yes, I am. USB, am I even looking in the right library? I am having one of those days. USB-C, no, I'm looking in footprints, I think. Superhouse connectors, no, this is correct. So tag connect is the other thing where it is, there we go, is the other thing where, oh, that's why it's looking stupid. It's total brain fart moment. I was trying to add it in the, there we go, vertical. I was trying to add it directly into the board layout instead of into the schematic. Here we go. So here's a vertical format, and look at these pads. So these are, well, I'm not sure whether your vertical excuse me, Stephen, I'm not sure whether your vertical one had pins or pads. So pins would be pretty horrible. With pads, you've got to drop it down through, use vias or vias, and drop it down onto other layers, because if you try to route out from around these vertical mounting pads, like if you route out from here, then you've got to try to snake it in through here, and you've got to snake this one through here. It gets really, really tight around this area, and you've got these holes on the end in this particular one. There are different footprints that have, okay, so Stephen, yours was through hole. Yes, same sort of issue though. You've got this problem that you just do not have room to route the traces out from here. And what's really annoying is that you've got to cross-link as well, because you've got to link data positive and data negative diagonally across the connector. I can't remember which one's D plus and D minus, but you end up with the usual problem where you, in order on the connector, it goes like D plus, D minus, D plus, D minus, and you've got to link the pluses together and the minuses together, which means you've got to loop around, and then you've got to, yeah. So you end up with a diagonal cross connect on the data lines in here, and then you've got to also cross connect the, which pins is it? There are 2 charge pins, but you don't have to cross connect those. There are a couple of others that end up being a pain. Power, of course. So you end up with a really tight little puzzle in here with changing between layers in order to be able to stack everything and then route it out around the mounting holes. And the same sort of thing here. So we've got this mounting hole here. This is a stake. It's not a metal pin, but then we've got the metal pins there. This is just a stake, but it's really annoying being there because when you do the, it's close enough that when you pour the polygon around this, like if let's just see if this does it. I'm going to pick this one up, move it down, stick it onto a part of the board. Need a clear bit of board. There isn't one. There, that'll do. And let's see if no, that's not going to be an indicator. So if I switch back to here, let's, what are we going to do? We'll connect up a couple of ground pins. Let's just do that. We'll go whoot, whoot, and link ground. Oh, this will do. That one, link that one to there. Oh, and that one's got to go to there and to there. This is a, I don't like this particular symbol. I've changed my USB-C symbol. It doesn't look like this at all anymore. This is an old symbol. And if we now go back to the board, no, not that, I want to go to that, and I want to go to there. Okay, now, now we'll pour that polygon, and look at this, we've got a ground pin here, we've got a ground connection here on that pad, and the polygon pour has not been able to reach it because the design rules prevent the clearance. You see this clearance boundary here on pin A11. This polygon can't get close enough to actually contact that pad. So what you end up having to do is like manually route. So I've just used the route tool here, connect to the pad. Let's just, oh, it's a 0.254 trace. Let's just go down to like a 0.2 or something. And route out to there. So if I now rip up the pour, you can see I've got a trace that is just dangling. There's a, it goes nowhere, but it goes into the region of the ground pour. So now if I run the pour again, we now have an electrical connection, but that's in breach of the design rules. The whole thing is just a pain. They're not fun. Yeah. USB-C, I know, I've ranted about USB-C before. I am going to try to avoid ranting about USB-C. Everybody else can do it for me. Okay, so, Scott says, newest revision of my little module programmer boards have gone to USB-C. Yes. David says there are some seriously sadistic component designers. So Scott, your programmer modules, would you care to drop a link in the chat? I'm interested to see. What sort of programmer modules are they? What are they? What devices do they connect to? Yeah, I use USB-C too. No, USB-C too as well. I complain about USB-C all the time, but I use it. I don't... Actually, the last time that I used something that wasn't USB-C on a board would have been on... It was on one of the wheelchair projects. What was it? The wheelchair... Would have been the wheelchair breakout, which was about 3 years ago. Like the control system breakout. And the reason for that, in that particular case, we decided to go for USB. I never get it around the right way. The big square USB connector. USB-A or USB-B, whichever one it is. Because it was going on a device attached to a wheelchair, and we wanted it to be able to pull out easily if something went wrong, like someone tripped over the cable, or if the wheelchair moved. Say you were plugged into it and then you move the wheelchair away from the computer. We didn't want it to rip the computer off the bench, which would probably happen with something like USB-C. The big square USB connectors tend to pull out much more easily, so that's what we went for. But that was the last time that I've used, and that was an exception. So for quite a few years now I've been using USB-C on pretty much everything. Oh, oh, Scott says, expecting to hand solder my first USB-C this coming week. Okay. Oh, Scott says, give me a moment, I'll toss a pic of one I'm doing this week into Discord. Awesome. Austin asked, are we talking 2.0 or 3.0? I use USB-C connections with USB 2.0 protocol because I only use it for, I just use it for serial comms. It's like Arduino sort of stuff. I like the connector in terms of its usability from the end user point of view. The plugging it in a bidirectional way. Oh, my throat is not good today. 1 second. And because I was rushing, I didn't even get myself prepared with a drink or anything. I should go and grab a drink. I also feel like I am in hyper mode just because I was rushing for like an hour and a half or 2 hours or something leading up until the live stream. Normally I start on the live stream and I'm kind of a bit dopey, but at the moment I'm still on the in rush mode. Henrik asked, who is going to my barbecue? That's a good question. So just as a reminder, Scott, I will thank you. I will check Discord soon. Because it is second Sunday of the month today, it is barbecue day. So if you're in Melbourne and you want to come along to the Super Lab in Bayswater, I won't give the full address right here, but it's outer east. Oh, Keith, cool. You'll be coming. That's good. Henrik says, grab some sweets. Yeah, I still have some sweets. I ate all of the chocolate lolly things. They are all gone. But I still have a little bowl over in my little coffee snack area with some of those other sweets in it. Scott says, I comfortably solder everything with a 1mm spade tip carefully. Yep. Oh, Trady says, come on, John, you're meant to be make being in electronics tech fun. It is fun. Challenges are fun. Yeah, Austin says, granted, tolerances have gotten better over the years, which is nice for tight traces. Yeah, I'm kind of stuck in the past. I end up using large traces more than I need. Well, this is a fairly old project. What year was this? It was a few years ago. What was I using? What is this trace? It is a 0.3048mm. What is that in inches? I've been using millimeters. Like I've been 100% metric on all my designs for quite a few years now. But you end up with weird things like 0.3048 as a track size because that is a multiple of thousandths of an inch. So what is that in thousandths of an inch? Let's just change the grid type. It is 0.012 of an inch. So 12 thousandths of an inch, which is pretty big as tracks go. So that is 12,000. I often use 0.254mm, so that's 10 thousandths of an inch, which is way above the minimum track size that most PCB fab houses can do. Oh, Sion! Haha, moo. Thanks for coming along. Oh, Wild. Thanks for coming along too. Oh, Gavin, you're coming to the barbecue as well. That's good. Wild says, sad, too far away from Frankfurt for a barbecue. It is, unfortunately. I'd like to come and visit Frankfurt. That would be nice. It would probably, what is it? It's July. So July in Frankfurt, it'd be quite warm, wouldn't it? What is it like over there at the moment? Probably a really good time of year to be there. Okay, Scott says, brownish pick is an example of goofy routing. So this is in relation to Discord. I don't actually have Discord open right now. I'm going to open it, but I'm going to keep it off screen until it is. David K says, are you sure it's not 12 hundredths of an inch, not 12 thousandths? That is possibly. No, it is 12 thousandths, I think. Here we go. Okay, so I have just opened some stuff from Tinker. Let's, I just want to make sure I'm not going to disclose anything if I bring this up on screen. Okay, I think I'm alright. Hang on. I'm going to pre-open these in a browser window so that I can then bring it up on screen. I assume that it's okay to show this stuff publicly, Scott. Nerd Mage, module programmer. Nerd Mage. Alright, so where are we? Here. Going back to this one. So Scott's comment was, brownish pick is an example of goofy routing. Orange ones are the current programmer. Okay, so goofy routing. Goofy routing? Where is the goofiness in this? This looks like good routing. That's, yeah, it's tight. But I don't see any goofiness. I just see goodness. It's there's obviously very careful component placement on this. Like, look at this. See how these resistors R11, 1 and 2 are directly adjacent to the pads that they are connected to. And then you can see there's a via that drops down to get to where it needs to be. It's been a bit of work that's gone into this to make that all fit, but doesn't look goofy to me. Scott says find the 3v3 connections. Alright, here's the challenge. 3v3. That'll be on, looks like it's the bottom layer of the PCB unless it's an intermediate layer. So we've got a ground plane on the top, and oh look, you can see that the pore has not quite reached through that little gap. That's unfortunate. Possibly goes under that component, but can't tell. 3v3. Alright, so it hits that pad there, and then where does it go? My guess is that these, so C8, C9, etc., C5, C4, C7, these are probably decoupling caps. Oh, hang on, is this, what is this? Is this an RP2040? I'm just looking at this because this power layout is looking mighty familiar. This really looks like, recently, this looks very much like the 1v2 decoupling and the VCC decoupling on an RP2040. And yeah, this row of caps along here, this cap over here. So one of these will be, I think C7 is, well, that's ground at that end. But yeah, where are the 3v3 connections? They must all be under the chip. Oh, Scott says RPi Pico in an actual usable format. Yes, nice. Oh, and yeah, that's the flash memory chip up the top there. So that's ground. That I can't specifically remember which of these decoupling caps are on the 1v2 line, like the 1v2 rail or the 3v3 rail. So buffering. Do we have problems with NBN again? So it looks to me like 3v3 is probably coming up from under the chip, and then it is going out to the decoupling caps through the pads. So somewhere under the chip there will be connections to 3v3. So for example, if C7 is a decoupling cup on the 3.3 volt rail, then 3v3 would be coming up underneath, connected to a pad, tracing through and coming to the decoupling cap. Yeah, I suspect that if people are having problems with the stream buffering, it is most likely at my end. Alright, so that is the one that you say is goofy routing. I say that's good routing. Okay, so this is the programmer that matches that other board, I guess. So it looks like there are 6 pads across the bottom. Does it match that one? Is it only intermediate? Oh, no, stick your ESP12 or 07 here. Okay, this is quite different. It's this is a programmer for an ESP12 or ESP07 module. So these are spring connections. This is really cool. Where do you get those little springs? I just recently, where is it? Right here. In fact, it happened to be on the bench right in front of me. I have just bought a Vroom 32 programmer. Let's go to Mr. Overhead Camera. No, you can't see that. Let's go to Mr. Microscope, which is currently flickering on and off. So I'm going to see if I can possibly improve that situation just by jiggling the top camera a little bit. Nope, it's not stable. I need a new camera. But in between the flickering, you can see it's got these little pads that are these little springs. So you drop the module in, and so you can put a Vroom module onto this board. I'm going to switch away from that because that's so annoying. You can put a Vroom module onto this board. Like here's a Vroom, and clips into place, kaboink. And then you can load code onto it, and it's got breakouts for all of the I/O, so you can connect up to it. You can get a Vroom module working before you even solder it down on DB. And it uses those little, it's got spring pins coming through the board. You clip the module down onto it, and then you can program it before you attach it. And Herdmage module programmer. This half is just here to be snapped off and made into a base plate. If you can read this, you forgot to assemble your programmer. Ah, cool artwork on here too. Little rabbit. Nice work, Scott. This is cool. I've never actually built a board with these little spring contacts in them, but I really like that. Scott says, just PM'd. Okay, yes, here we go. Here is going to be another view. So Scott just sent me this. Said the board view with fills off. Okay, so we can see. Oh, I'm getting a phone call from Mitch. I can't really answer it on a stream, which really sucks because I haven't spoken to Mitch for ages. Sorry, Mitch. So this is that same board, but we can see through it with our X-ray vision now. And oh, rabbit, because it's a rabbit hole project. Okay, so this is that same, this is this board. Okay, so now we can see what's going on with all of this power. Here we go. So this C7 up in the top right here, which is one of the decoupling caps. You can see it comes down, and there is a via just under the corner of the IC. It's a little bit hard to see my cursor there. And so I'm up in the top right corner of the chip. And then it's connected to the top right pad. So if we go back in this view, this track comes down, and there is a via right about there where my cursor is wiggling around. And it's connected to this pad, which is a 3.3 volt rail, and then it loops around and connects back up. Where does it go? Loops up, connects to this pad, and then this one has its own power rail that loops around. Yeah, I think this one might be the 1.2 volt rail coming around here. I could be wrong. Something like that anyway. Yeah, technically 3.3 volt and ground are invisible because they're fills. Yeah, okay, so they're on a, it's a via that just connects through to a fill that's on an intermediate layer. Yep. Okie dokie. Nice. Now, any moment now, I am going to pull out the box of stuff from Henrik. Oh, okay. Scott, I was asking about the little spring contacts, and Scott says solder party. Yep, those are flexi pins. That's what I'm using. Austin says solder party.docs flexi pins. So this is what those pins are. Cool. I should order some of these. It'd be very useful to make up little test jigs and things. Flexi pins. I'm going to leave that tab open for future reference and then possibly find some and order some. Okay, 1v1. Thanks, Scott. My memory was wrong. I thought it was a 1.2 volt rail, but it's a 1.1 volt rail. Okay, so where are we? We are not that button. That button. We are here. I might need to zoom in a little bit, but we shall see. All right, so a couple of weeks ago, a few weeks ago, 3 weeks ago, whenever it was that I had Henrik's boards all pulled out. This is a quick little refresher. These are modules that Henrik was doing for his for a school project, making up some things that weren't available that he wanted to use. And this is what I assembled last time. So this is the AT-Tiny85 programmer and some other boards that go into that modular system, which I can't remember what it's called. What is this one? Oh, that's a fuse. I don't think I even looked at this one last time. I'll pop that cover off. Yeah, there's a fuse in it. Cool. Yep, little trim pot. Okay, so we'll put these ones back in because we had a look at those last time. Let's see what else we have to experiment with today. What is in the box? Oh, that's right. This is the very bizarre looking reed switch, the huge one, the monster reed switch. I feel like doing a little bit of soldering. Oh, that's right. This is what we assembled last time. So this is an Arduino Mega shield, and there is the earlier version of the PCB still in the bag, and this is the current one. I'll put that back in the bag. Let's see what else we've got. Oop. So what's this one? This looks like a whole lot of switches go on it, perhaps? Okay, I'm curious, but just because the shape of this one is so weird, I'm going to open it up and let's find a knife and see what's going on with this board. Okie dokie. Is it a shield? Yes, it is. It looks. It's a. It's an Arduino shield, but in a very strange form factor, and it's got a whole bunch of surface mount parts that go on it here. So, what is this? Does it have any label on it? No. Can't see what it, if it says anything. So it looks like. So my guess is that these are LEDs. These will be current limiting resistors. And the switches, I'm not sure what they're for. There's no ground plane on it. It's just fairly simple traces. It looks like it's traces directly to each of the I/O pins. Okay, so my guess, okay, without Henrik telling me anything, I'm just going to, okay, Henrik says it's an Arduino Uno I/O tester, hard to explain. All right, I am going to take an educated guess, without Henrik explaining it, about what this does, just based on what I can see on the PCB here. All right, what it looks like is that we have on each of the I/O pins. Hang on, I'm going to zoom this camera in. Zoom in, and then I'm going to have to focus, which means that it's going to drop into focus assist mode temporarily. Oh, got to get it about right. I think it's about there. Close enough. And then it will drop out of focus assist mode. Give it a couple of seconds. It'd be nice if it stayed zoomed in this much, but it doesn't. Okay, so on each of the I/O pins, this is my guess. Okay, it is connected to, each I/O pin is connected to 2 switches and some LEDs. The LEDs are facing in opposite directions, so these LEDs are in it. No, switch selects which way LED you want to use. This lets one LED one way, the other is the other way. Okay, no, you're not meant to explain it, Henrik. I meant to figure it out. Okay, so because the LEDs are facing in opposite directions, my thought was that if you made the pin go high, one LED would come on, and if you made the pin go low, the other LED would come on. But are they connected to the same power source? No, they're not. Okay, that sort of confirms my idea. What I don't get is why there are 2 sets per pin. Oh, that's for that pin, that's for that. Oh yeah, that makes sense. Okay, so there is what it looked like initially is that there was a row of LEDs associated with the pins, and then it was doubled up on this side, but it's actually interleaved. So this set of LEDs and switches for the first pin, this set of LEDs and switches for the second pin, then that one's for the third pin. So they alternate top and bottom just to be able to make them all fit. But it's one switch and a pair of LEDs for each of the pins. All right, where do these traces go? Just flickers like crazy. Okay, so we got a switch, that'll be common, so I/O goes to the switch, it goes to there, or to there. Okay, so with the switch in one position, it directs power through one LED. With the switch in the other position, it detects it through the other. It puts it through the other. However, if the pin is high or low, the LED will illuminate or not illuminate depending on the position of the switch. So with the switch in one position, the pin needs to be high to illuminate it, and with the switch in the other position, the pin needs to be low to illuminate it. Does that seem like a reasonable analysis, Henrik? Have I got that correct? So what you could do is flick all the switches in one direction and then drive all the pins low, and you should get one, so you get the different status, and then you flick the switches and you should get the opposite. So if you were alternating, say, red and green LEDs, so all the red in one direction, all the green in the other, then you would get a row of green, or you get a row of red, or you get nothing. And you would be able to see if, very quickly, if one of the pins was high or low when it shouldn't be. So the way I've done that, oh, thanks, Henrik. What this reminds me of is test jigs that I've done in the past for Arduino related things. I'm just having a look. About a week ago, where is it? Up there. Okay, test jigs. About a week ago, a guy came over from a company down in Dandenong that makes high-end test jigs, and what am I trying to find? I don't know what I'm trying to find. In fact, the particular thing that I have in my head I don't think is in here. So what I've got here is a whole box, oh, it's out of focus, a whole box full of test jigs of different types for many projects that I've done over the years. And there's one particular type of test jig which is not in here, which is very similar to what I did, was interconnect pairs of I/O pins. No, it's not in there, so there's no particular thing. So on that test jig, what I did was bridge across, basically. So what you do is you take the first I/O pin, bridge it to the second I/O pin, take the third I/O pin, bridge it to the fourth I/O pin, etc. So you basically have a whole lot of little pairs of jumpers. And then what you can do is turn all of the I/O pins into inputs with, say, input pull-ups turned on. And if you're testing a board that doesn't have pull-ups within the microcontroller, then you can add them onto the test. Actually, you couldn't see it. So, but just to repeat myself, so you make a jumper that goes from the first I/O pin to the second I/O pin, from the third I/O pin to the fourth I/O pin. So you've got pairs of bridges, and this would be done on some kind of a test fixture that attaches to the Arduino or whatever the board is. So you set them all to input pull-up, and then what you do is you drive the first pin, you change the first pin into an output pin, and you drive it high. And then you measure, you put every second pin into output mode, drive them all low, then you drive the first one high, and you check that you've got a high input on the second pin, and then you check that you still have low on all of the other pins. And that way you've checked whether you've got solder bridges across. And then you reverse it, you drive this one low, and then you drive this one high, and then you do the process again. And by doing like a particular pattern of things, you can determine if you've got cross connections between any of the, how is this done? You also need to be able to check for solder bridges between adjacent I/O pins, and I honestly just can't remember. It's 10 years ago, longer, must be like 13 years ago that I made that particular test jig. And it then allows you to check whether you've got solder bridges between your pins. And you can also check that there is a continuous connection. So if you've got, say this was an Arduino board, you had a microcontroller on here in the middle, it verifies that your connection from your microcontroller is going all the way to the header pin, and you don't have an open circuit somewhere on the board. I've got buffering, bad stuff happening. Thank you, NBN. I don't even know if I'm online right now, because there's nothing in the chat, and I'm getting errors coming up in the YouTube console. So maybe you can see me, maybe you can't. I don't know. Oh, you can. Okay, thanks, Austin. So, okay, cool. Thanks, Henrik. All right, so this one, test a little Uno tester. Nice one, Henrik. Now, what's this one? What I should have done is got out some solder paste and done some actual reflow. All right, what is this one? And hang on. I'm just going to get all of this back out again, because I might have to be a little bit selective about which things I go through today, because we're not going to get through all of it. There's a breakout, the high frequency relays that we were looking at last time, relays that were rated to some crazy high frequency, and those, I can't remember if we looked at those. Those, not yet. It's a potentiometer, variable resistor. There's this little module that we looked at very early on. There's this. I am going to get this out. Now, I wish my microscope was behaving itself a bit better. because I kind of do feel like doing a little bit of surface mount assembly. Come on, I'm going to fiddle around with this and see if I can get the microscope camera to be behaving itself a bit better. I've just pulled the power out, plugged it back in. It's very frustrating that this camera does not work properly. No, it's still just flickering its output on and off. And I've changed cables and things. I don't know what it is. I think it's a fault with the actual camera itself. Oh, no, that's interesting. It now seems to be stable. If I switch to microscope view, it is temporarily being stable, which means I'm going to grab solder paste out of the fridge. And I should have done this earlier, but I'm not prepared. Of course I'm not prepared. Oh, hang on, did I just see that camera flicker again? I hope that it does not. It'd be nice if that was working again. All right, I'm just going to start warming up I've just got the syringe of solder paste out. Let's see what is going on with this board. And zoom out. I'll zoom it back in for actually putting the paste on. So this is a whole lot of LEDs. Rizzuti? Is that what it is? Amanda, $5 for the new microscope camera fund. Thank you. Yeah, I was looking at them on AliExpress last week because it's been frustrating me so much. All right, so what it looks like is that we have a whole lot of LEDs going on here, and Henrik has even supplied a big strip of LEDs. These look fairly large. What type of LED are those? Yeah, with with like the random buffering will mask the random camera flicker, says Scott. Yeah, it's like the two layers of Swiss cheese align and all the holes align. That's what we want. All right, so yeah, it looks like in that gap there, then in here, so it looks like it with a Rizzuti. I don't even know what that's along between these pads. And here I'm just trying to trace where this goes. Okay, all in parallel with those. Where does that go? Does that connect to there? That is, no, I can't follow it. I could buzz it out quickly enough. Let's see. Are they all in parallel or not? Let's just see. So those are, looks like they are all in parallel. Oh, hang on, maybe, whoop. Yep. All the way across to here. So all of these LEDs are in parallel with no individual current limiting resistors. Is that the way this is meant to be? Yep. Okay. Henrik said, when I assembled it, did every one of the LEDs, but I've sent you for all of the pads. And yes, they should be. Okay, so that means we'll need to supply it with, so if they're all in parallel, it'll be whatever the voltage drop is of the LED is what we want to supply to it. So let's pick a topic to talk about. I'm not going to do this whole board. I'm just going to put solder on. Let's see. Hang on. I've got to get the focus set for the camera. Which is about there, give or take. Okay. This solder paste is, it's a bit cold and not flowing very well. So, okay, so if they're, I don't know what color those LEDs are, but if they're red, what is a red voltage drop typically on an LED? 1.6 volts or so. Green is like 2.1 volts. So we'll need to supply whatever is the appropriate voltage. Also, I'm just going to hit this with the hot air, I think. Could do it with the soldering iron. Now let's do the bit of solder paste kept coming out of the syringe. Now, which way do we want? So there's no polarity marking on there. I'll have to work that out from just where the traces go. Now, time for some LEDs. LEDs. It just occurred to me, I wonder if, oops, I just dropped some LEDs. This could be a sneaky way to get me to do contract assembly. Oh, they're in pairs. Ooh. This is not what I expected. This is very interesting. Okay. These are square-bodied LEDs. Is this what you expected to be sending me, Henrik? I've got to fix that focus. Which way does it go? I think that's about as focused as it gets. So these LEDs are, these are RGB. You can see that, I'm going to get the zoom even more right in on this LED because this is interesting. Get it right in on there. Is that a bit too far? Right about there. Okay, so if you look at the die on this, you can see there's a little die of the LED in here, and then it's got these connections, these bond wires coming out to the pads. So this is one, I'm just going to pick it up with the tweezers so I can move it around. So this is a single case. It's the size of like two 0603 LEDs side by side. And it has 4 pads instead of 2. So you can see that somewhere there will be a common pad, and then it's got bond wires going out to all of those pads. So, question is, what sort of LED is this? And how does it behave? So, hang on. I've just got to make sure that I don't lose them, because these are not normal LEDs that I have replacements for. Things just got really interesting, Henrik. Okay. Now, yes, one LED for one pad. Henrik says use 2.8 to 3 volts. It was like 2.8 volts. And hot air is cheating. Well, I could go for multimeter on diode mode, says Austin. Yeah. Let's see. I could go for... I also have my handy dandy little LED tester here. So I'm just going to switch back to overhead camera and do some checks. Where's the camera? There it is. Okay, there's the LED, that tiny little thing. And I'm just going to randomly connect to some pads and see what happens. It's kind of awkward because I've got to, I don't know anything about the pin out of this LED. I'll turn it around. Try it. Oh, there we go. There was red for a moment. There's red. Red. What if I go to there? More red. It's red that way. It's red there. Not red there. So is there a particular red there. Right, I thought these would be RGB LEDs, but maybe they're not. So I don't actually understand why there are 4 pads on these if it's not to make different colors, because these 2 pads seem to be the same. Like if I connect diagonally across there, it goes red. If I connect it directly across there, it also goes red. If that pad doesn't seem to do anything, oh, maybe it's from this side. It's very hard to put pressure on it. No, I can't really do that while I'm holding the tester. But in any case, you got me intrigued. Just keep the power, says Henrik. Okay, now I'm going to go back to this mode. And Henrik, because I don't have a data sheet for this, I don't know which way around this is meant to go. And you see how maybe that way is the marking on the anode. So, oh, I see, it's not 4 pads. I was misinterpreting this. Okay, so it is an exotic case, but it's actually only a single color LED. Right, so it's like it's got 4 pads, but they are directly linked across here. So that means, hang on, which way around does this go? It kind of doesn't matter, as long as I'm consistent and orient them all the same way. So that is, so I think I put that first one on backwards technically. So I think my guess is that that's the anode and that's the cathode, but I could be wrong. Oh, Don, hello. Cold and windy in Auckland today. Yep. Oh, Henrik says, okay, later you'll see you just needed to hold the power. Oh, okay. I think this is getting fancy. I think it's going to flash. That's my guess. All right. Now, I don't know if I'm actually doing this the right way around, but I am going to put them this way. So the pads that these are going onto are, I need to do some of these with the soldering iron just so that everybody's happy. So, oh, doing this reminds me, I've got news on the pick and place machines as well. So I will give you an update on that in a little bit. But I want to show you a video, so I won't talk about that too much now. These are kind of awkward to put on because the package is large and square. Hang on, I'm going to zoom back out again now because it's now that we're just doing board assembly, we don't need to be looking at the individual. We don't need to be looking inside the LEDs anymore. Okay. Now, all of these LEDs are connected in parallel, and there is just a pair of power connections here. So one of these will be positive and one is negative, but it kind of doesn't matter which way around I put the LEDs because I can just reverse the power connections. There's nothing else in the circuit, so we're not messing anything else up by doing that. All right, I'm gonna stop fluffing around and just start putting some parts on. That way, I think they're all oriented the same way on the board. Hopefully. Hopefully Henrik aligned them all so that they're all left to right or right to left, whichever the case may be. As long as they're all the same, it should be fine. Now the thing is, what would be interesting is if you did something like this with 2 different colored LEDs and you reverse them, So I've done this on a, in fact the water cannon project does this. On the motor drivers, on the output side, I've got LEDs, and the motor drivers, there are H bridges, so we can drive the motors in either direction. And what I did was put LEDs on the output, and I put 2 LEDs on, one red, one green, and they're just facing opposite directions with a single current limiting resistor. So if you turn a motor on running in one direction, the red LED turns on, and if you run it the other direction, the green LED turns on. So you can just glance at it and you can see whether the output of the motor driver is doing what you expect it to do. Oh, come back. So, getting back to that mystery phone call earlier from Mitch while I was on the stream, just in case Mitch happens to be watching, my guess is Mitch was wanting to know about the address for the barbecue. And some of you may also be wondering that same thing. The address is in Discord. It's in the Superlab barbecue channel. And the URL for Discord, you can, if you haven't been on it before, the invitation address is superhouse.tv/Discord. Should get you to a page with a link that takes you to the public invitation to Discord. Yeah, I know it's a whole lot of jumping through hoops just to get the address. So, which is a bit of a pain. Hopefully I put those on all the right way. Looks like I might have. All right, I'm just going to do this eye as well. And then we'll power this up and see what these LEDs do. What'll be really interesting is if they are flashing LEDs, do they stay synchronized over time? There'd have to be some drift. If they've just got if each of them has their own little internal oscillator, an astable multivibrator, which brings me, an astable multivibrator is the first project in Dick Smith's Fun Way into Electronics Volume 1 and Volume 2. That's teaching people electronics by stealth. Make a flashing LED. And hey, you've just made an astable multivibrator. Also known as a flip-flop. How many more do we need? 3. Okay. 3 more, and then I'm going to hit the hot air. Maybe I should do a couple with a soldering iron just to keep everybody happy. Also, the hot air is annoyingly noisy. Alright everybody, cover the ears of your voice assistants, unless you want me to turn on the soldering iron on your bench, because I'm going to say, Alexa, turn on bench 1. And now I have hot air. So I need a sacrificial piece of cardboard. Chuck this over here. And oh, I don't have a tip on the hot air because I was using it a day or two ago to heat up a large area of something and I took the tip off. I probably should have put it back on before doing this. Where's the camera? There. So have we worked out yet what Rizliti means? The translation for this thing? So I'm just going to be making it say Ri because I don't have the other letters on it. Come on. Time to barbecue some LEDs. Oh, Henrik says, the sync you'll see when you power it on. Okay. Oh, Henrik has retracted some messages. What's that one? Just a bit. Kim said, is it some magical LED with its own internal current limiting feature? Oop, I wasn't even watching. I was reading chat and I was pointing the hot air away from the PCB. No, I suspect it doesn't have its own inbuilt current limiting. So that the voltage drop is going to be an issue. All right, those have all reflowed. So I'm going to make sure that I don't give it more voltage than it wants. Now let's just chuck this back under the microscope temporarily. And have a, oh, they're not exactly straight, are they? That's actually an interesting, look at this, look how jagged these all are. They're all over the place. Normally the surface tension would pull everything straight, but I think this is a function of the fact that the footprint does not match the LED very well. So you can see, here's a good example. Let's zoom this one in. Okay, you can see here, the end of the LED, it's got two little scallops on it. So it's got metal all the way across the end with two scallops. So it's like it would connect to two pads or one large pad, but the pad isn't quite wide enough to cover from edge to edge of the LED, which means that, oh, hang on, that focus on the camera is bad. That's a bit better. So if I use this as a pointer, the edge of the pad is there, but the edge of the LED is right out here. And the edge of this pad, of this side of the pad is here, and the edge of the LED is here. So the LED is wider than the pad, and what it has done is the surface tension, because of the little scallops, has pulled it sideways so that it's trying to align against this scallop, and on this end, it's trying to align against this one. You can see that this one has ended up moderately straight, this one's reasonably straight, this one's a bit twisted, that's straight, that's straight. So these would have pulled themselves straighter if the pad was a better match to the end of the LED, so that the surface tension was better. Okay, let's go back to here. So any, oh, Chip said, how many bags of ice today, Jono? Probably only need one, maybe. David said that's a first class bang up job. Oh, Henrik said Risliti is an Estonian electricity company. Ah, okay. Interesting. All right. What am I going to use? So I could just stick the LED tester back on it, but I wonder if it'll have enough power. It may not. All right, this is going to be kind of a crude test, but let's just try this. I don't even know what the polarity is of these connections. What have I got it set to? 5 milliamps. It's on a fairly low current setting at the moment. This may not do anything. Oh, it does. But I think we need a little bit more power. Oh, they're changing color. Look at that. They've gone green. And now they're going, oh, they're slowly changing. They've gone blue and now they've gone to red. You can see that they're flickering a bit. We're not getting enough power out of this LED tester. Hang on, I'm going to put the current up to, what? I'll put it up to 20 milliamps. Ah. And see if this works. I can't even remember if this is the polarity that I had just a moment ago. No, it's not. All right, switch it back around, put it on here. So they are not flashing LEDs, they are color changing LEDs. Here we go. Hang on a second. Alexa, turn off the office lights. Okay, that's better. Now we can see it. So green, and then it's going to blue. You can see a couple of them went red slightly earlier there. Now they're all back to red again. And then they'll change color again is my guess. But over time they're going to get more and more out of sync. You can see that there are a couple of them that are changing before the others. This is cool. These LEDs are interesting. Thanks, Henrik. It's funny how something like this, when I first saw this, I thought, oh, it's just going to be LEDs and it'll just be something that lights up a word. But using these unusual LEDs makes it a lot more interesting. All right, then it goes to green, and some of them are into the red phase. You can see they're getting out of sync now. Over time, it's going to end up being more and more like a rainbow, I think, because their sync will... Oh, you need more power. Okay. Need more power. All right, in that case, let's go for a... I'm going to turn on the bench power supply. And I'm going to set it to... What was the voltage you said earlier? Let's see, where was the voltage? Somewhere back here. Oh, Amanda says Risletti is Maltese and means results. Okay, too little current. All right, not getting enough power onto it. Somewhere. Oh, I don't know. Somewhere earlier back, Henrik said how many volts to stick into this. So I'm just going to start with about 1.8 volts and then we'll work it up from there. And whoops, and we'll see what we get to. So where are we? VSET 1.8, go. Current limit, it's set to 6 amps at the moment. Let's go for something a little bit lower. Let's go for 200 milliamps. Not that we should need that much, but well, don't know. Seems to be a reasonable sort of safety limit. I'm going to try putting these in from the back this time because I should be able to hold it in a position that is then easy to see, like that. Turn on the power supply. Did I get it around the right way? Ooh, Imi just signed up for 5 months. Wow. 1 bag of ice. Okay, cool. Yes, thank you. So, in the past, hang on. I'm just going to switch this around. Yeah, previously we've got 3 bags, I think. And I think it's probably been too much. And also, it's not particularly warm here. It's kind of cold already. The drinks don't need a whole lot of chilling. They're sitting out in the factory area. Oh, I'm just trying to bend those pins away from each other. Here we go. Oh, that's better. Okay. Hang on. 1.8. So I'm at 1.8 volts at the moment. I think that's probably not enough. I'm going to go VSET 2. Go. No. Turn it off and turn it back on. No. You can see that some of them... Oh, what is going on here? Maybe I need a little bit more voltage. Some of them are not powering up properly, and the other ones aren't changing color. All right, I'm going to go for VSET 2.2, go. I'll turn it off and back on again, so we've got a clean start. Not right off, give it a couple of seconds, back on. Some of them have come up with green and some with red. And I have a feeling that I probably need a fraction more voltage. 2.8 to 3 volts, says Henrik. Okay. Cool. Yeah, so Chip, it's kind of, this is getting back to the bag of ice thing. Imi says, 1 bag of ice it is. Chip asked me how many bags of ice earlier. So, if you want to get 2, that's cool. I don't know. I just think we don't really need a huge amount. We've ended up with a bit more than we've needed previously. Okay, so I'm going to go for a VSET 2.8. Go! Whoa, that's bright. It's very bright on camera. Right, I'm just going to turn it off so we get a clean start. Turn it back on. And it's... So this is 2.8 volts. It's currently pulling 120 milliamps for just these LEDs that are currently illuminated. And right now, Oh, they're going rainbowy. It's not really coming through on the camera as well. Like in real life, this is blinding. It's so bright. Needs a diffuser or something. What can I stick across this to diffuse it? I've got yellow post-it notes here, but the yellow then changes the color. What do I have? I've got a napkin here with some solder paste on it that I was using to wipe off solder paste previously. That just diffuses it too much and it just looks white. Slowly changing color. Yeah, that is kind of cool. David says sheet of white paper. Yeah. Oh, where are we? Johnny said, so the LEDs don't come with internal resistors. Okay, so Henrik said that's why I used every one LED. I don't understand what you get by that. So do you mean that you didn't put all of the LEDs on? Or, yeah, I don't know. But what I can see in real life here is actually you might be able to see this better now that this is so bright. Alexa, turn on the office lights. Amy says, on our way with one bag of ice. Also, I used my one free highlighted message for the pursuit of the barbecue, of ice for the barbecue. Thanks, Amy. So I'll see you and Chip soon. Yeah, so now that this is bright, I've got the office lights back on and you can see it a little bit better. So basically we've got rainbow effect, and when I look straight at it, I get stars in my eyes. I can hardly look at it. Is it changing? Yes, it is. It is slowly cycling through. On camera, this looks like they're almost all white. There's not a whole lot of variation in it, but looking at this, they're actually different colors. They look like they're blending together, but these ones down here are like a really bright reddish pink, and then up here it's more of a red, then there's a yellow, there's green up here. Down here it's yellow down here, and then sort of pinkish color here. But it just looks white on camera. So yeah, it's a pity that cameras don't have the same color reproduction as the human eye. But this looks cool. Yeah, those are really interesting. Peter, now a silver supporter. That is interesting. I'm going to turn off power so I can let go without fear of shorting the connections. Nice one, Henrik. You know, these are really quite intriguing. Henrik has sent it was a fairly small box. This is the box that had all the stuff in it. But there are so many things in this that are just unusual, like high frequency relays and these color changing LEDs. You've certainly kept me amused, Henrik. I like seeing things that I haven't seen before, or seeing things that I have to work out. So what is with this one? And if anyone is coming, for anyone who's coming to the barbecue today, you can see, well, that's intriguing. You can see some of Henrik's boards. So this particular thing, is this solder? Ooh. Yes, I can hear the car revving. That is Chip. It's just pulled up in the driveway. So some solder. I've got plenty of solder, Henrik. Why did you send me solder? Hang on, what's this? Peter's talking about brain injuries. What's this? Peter says, thankfully it wasn't up in a tree, so at least my brain injuries cannot be John's responsibility whatsoever. Peter says, I fell out of the clubhouse for a while. I'm back. Yes, oh, Johnny says, welcome back, Peter. Ah, okay. I was reading the messages in reverse. Just because I'm strange. So they didn't make a whole lot of sense. Okay, so is this a universal USB interchanger? Oh, look at this. It's USB-C with through hole. Exactly what we were talking about earlier. This is a whole lot of USB-C connectors. I don't know what it does apart from that. Does it supply power to USB? Does it allow you to connect any random USB cable to any random thing? So what we've got here is, it looks like we've got pairs. So we've got two of these. Whoa, these are weird. That's really weird. Look at this. It's USB-C and that is USB-B, I think, in a vertical format, like a dual footprint. What the hell? I've never seen those before. And then these are regular horizontal. And then we've got these ones. And we've got mini USB. So we've got two of those. And then we've got USB-C in a vertical. Hang on, what is this? Is it USB-C? No, it's no, it's mini USB mini, I think, in a vertical format. So this board, it looks like there might be a couple. So those are the vertical format ones there. It looks like there might be some connectors. Oh no, that one is included. That's the vertical. Oh, that's vertical USB-C. I see. So that goes in there. So this is like a Rosetta Stone conversion thing from USB to USB. Is that correct? Micro B, says Stephen W. Yes. It's just a USB changer. Yeah, says Henrik. It's micro. Right. Sorry. I always get the terminology wrong when I'm talking about these things. It spins by itself. It's like a roulette wheel, a USB roulette wheel. USB roulette. Which connection do we want today? But these connectors, these are trippy. The fact that it's two different types of connector in one enclosure. And so we've got pairs of everything. So we've got that and that. Then we've got those two. We've got those two. I'll move this into place in just a second. In here. We've got these two. And we've got in here the little vertical ones that go in here. So this connector here, I don't know what that's meant to be. Is that another USB connection, or is that, well, it's got the D plus and D minus on it. So it does have all of the USB signals. But is that a USB connector, or is that more like a power connector of some kind that you use for connecting, like supplying power to all of these things? I don't know. But let's do some soldering. And we'll do it the old-fashioned way with a soldering iron. Okay, so there are some capacitors on here. But this is intriguing. See this? There is a blob there, and there is a resistor there. Okay, my guess is this is a power LED, and then there is a glob of hot glue on it to act as a diffuser. So that is what I think is going on there. So Henrik, you can tell me if I got that right. Oh, okay, so Henrik says, and you can solder USB cable to the center. Aha, got it. Okay, so just get a regular USB cable, cut the end off, and solder the wire straight onto there. What I will do now is, let's put on a couple of these connectors. I'm going to solder this one on. So, a bit of blue tack on the back. I probably won't do all of these connectors, but I'm going to do some of the interesting looking ones. In fact, I'm going to switch this to the microscope, but zoom out, because some of these footprints are quite interesting. And it's, it's directly related to what we were talking about before. What tip do I have? K-tip, that'll do for now. I'm going to switch to a different tip once I get onto some of those USB... Hang on, you can't see. Microscope, go. All right. I'm going to do the mechanical ones first to get the strain relief in place. They're going to the ground plane, so I'll just let it soak in a bit of heat for a while. Okay. And then I'm going to reflow it while pushing it in, just to make sure it's all seated down. All good. Okay. And now I'll do the other mechanical pins. Get a bit of thermal coupling happening through with a little bit of solder. Get some heat into that ground plane. There we go. Yeah, that ground plane started to warm up a bit now, so it goes more quickly. And do the data pins and power pins coming off the connector. The big chunky K-tip. Oh, that was a bad joint, that one there. None of those are particularly good, but they'll do. Aha! The visitors are here. Come on in.
Hello.
Hello. So there is the connector in place. G'day.
G'day.
I'm coming through on the phone. That might need to be muted. Yeah, so that was a dodgy solder joint there. Hang on, where's the focus? Lots of nasty flux in there as well, but anyway, you can see that's a bit of a dodgy solder joint, but it's okay, it'll do. Not my greatest work. So we've got the connector in there, and the one that I'm really intrigued about is the vertical format. Which way around does this go? Okay, you see this, I've got to find the right spot. This footprint here. Look at this. This is a dual footprint. Well, it's a single footprint and it's a dual connection. This thing that I'm just going to slide into view here has got USB-C there, and it's got two sets of pins coming out the bottom. So what we can do is, I'm going to clip this into place. I don't know if this is going to retain itself because of the tension on the pins. Oh, it does. Okay, that's nice. So that holds itself in place fairly well, but it elevates the PCB. So get that back up there. Once again, I'll solder the strain relief on first so that it's mechanically in place. It takes all the load off the pins, and then when the pins are soldered, they end up being attached in a position where the enclosure is stable and they're not going to have any stress placed on them. All right, solder the other pins on here. And before I turn it around, I'll do some of the pins on the USB-C side. Look how small the annular rings are on these connections. And that's just to make the clearances work on those through-hole pins. Improve the focus a bit. Well, hello, thank you for coming along. And there is, somewhere outside, I think there is a plastic tub.
Yeah, we saw a bunch of plastic tubs, but
okay,
work out which one you wanted for the ice.
Okay.
Get
yeah.
ready for the barbecue, Pete's.
Yeah, I hadn't got to the point of putting the drinks in a plastic tub, so I need to find a suitable one.
This morning, John, I don't think there's any worry.
No.
It's weird that I actually watch directly what you're doing. And it's much smaller than it looks.
Yeah, it looks huge on screen. Yeah, so that is the back of that combination thing. So you can see Chip's stomach there standing in front of the camera.
Is that on live?
Yep.
Belly button. Oh, that's awkward. Evils.
Okay, so this is the board. Whoops. So I've just put the combination connector on there, and we've got this other connection on here. So if we connect, so what I'm trying to get to is to find out what's going on under this little blob of hot glue just here. Yeah, I really think that that's a power LED. Henrik says, so it's an 8-way USB hub with the same serial port. Okay, so it's, yeah, Stephen says, I'm guessing that's not going to do wonders for your USB data signal. No, it wouldn't.
Of life.
Proof of life, yes.
Where's the camera? Yeah.
There.
I'll put them back now and stop them. Sorry, mate.
Stephen says, good thing his fly is zipped.
Oh, yeah.
Yes. Henrik says, also the regular USB on there is so that you can plug it in both ways. Yeah. Right. Where is the... It's on the wrong camera. There. Okay, so there are some... Yeah, this socket though, that is really intriguing. It's kind of a bit of a mystery why this socket even exists. Like the company that came up with the design of this, why did they design that? Do this combination that's got both of those USB connections on it as independent things. I suppose if you were doing something like designing a PC motherboard, you might want to provide both USB-C and USB-A. Is it A or B? I can never remember. I think that's the type A. Yeah, you might want to provide both on the motherboard. So what you could do is put on a couple of these connectors, and then you've got a row of type C and a row of type A. But then if you were going to do that, wouldn't you have like a double type C and a double type A? It just doesn't make a whole lot of sense. I mean, it's kind of cool having it on the board like this, but why would you have designed that connector in the first place? Very strange. Okay, I'm going to chuck, which of these bags is not damaged? That one's no good anymore. It's ended up being cut. Henrik says, I bought it from LCSC. Yeah, they have lots of interesting things. It's already 11:40. Time is getting on. All right, I'm not going to solder more onto this, but what I'm going to do, because I want to see what is going on with this, is I'm going to supply 5 volts directly into the power connections on here, and I want to see what happens. My guess is that an LED is going to come on. So VSET 5, got 200 milliamp set on the current limiting, and which way around? VCC, ground. All right, this is kind of crude. I'm just using the alligator clips and sticking them on. Let's see if there's a bang. Oh, no, there's just a green LED. Yeah, so, okay, so that looks like it's a surface mount LED with a glob of hot glue over it to act as a diffuser. And that actually works really effectively. As you can see on camera, I'm going to turn the voltage down because I want to, just going to go down to 4 volts. In fact, I might have to go even lower because it's so bright. Yeah, I'm going to go down to 3 volts. Even so, yeah, you can see that it is diffused and it just looks like a single big green blob, even though there is a small surface mount LED in the middle of that blob. That's an effective technique. That worked well. Cool. All right. What else do we have here? Let's have a quick look. Okay, I want to see what's going on with this. It's an Arduino shield, but it's got some strange looking connectors in it that from the outside of the pack, I'm not really sure what's going on. It looks like B and C connectors. So we'll get into that. What do we have? All right, so there's a shield, no silkscreen markings on that. Which way over does it go? That way. That is the standard shield orientation. And then some parts. What does this do? Alright, we've got a bunch of buttons. We've got a bunch of diodes. And I can see from the silk screen where those things go. So then we've got a ceramic capacitor. We've got some resistors here, 3 different values. So 4 different values, 120k, 12k, and 100 ohm. I only see 3 resistors. That's interesting. Maybe there's a resistor missing. What did I do? Did I just lose a resistor? I don't know. And where does the ceramic cap go? These are all resistors. Maybe one of these is meant to be a ceramic cap. And there's a footprint there for an OLED. So, and then these are RF type connectors, which go through that way. Okay, so what is this? This one is odd. Okay, so Henrik says, I'll send you the code link and etc. Groovy. Henrik says, sorry, maybe it's just missing, I can't remember. That's all right, I've got a lot of resistors here, so I should have all the different values, but, C104 goes there. Okay, let's stick these parts on. But I'm still intrigued to know what this actually is. Oops. What length do these need to be? Second, yes. Second, I'm just going to straighten these diodes out. Then bend them on my little bendy jiggy. Okay. Bendy. Yeah, so I don't know which of these. These are 5% resistors, so I can read those ones. But that one is a 1% resistor, and I hate reading color codes on 1% resistors. Although with this one, I probably can. It looks like it's, getting the colors, it looks like it's brown, black, black, black. Or brown, black, black, what's the last color? Maybe green? I don't know. That could be, well, it starts with a 1 if it's brown. Anyway, I'm going to measure it. I don't even bother trying to read those things anymore, so let's just start with sticking in the diodes. And while I am sticking in the diodes, I'm just going to mention something that is coming. Doesn't properly exist yet, but after all of the interest that has in kits and this sort of assembly stuff that has happened over the last little while, and all the discussions about fun way into electronics, etc. Just letting you know that funtronics.club now exists. Well, sort of exists. It's beginning to exist. It's the domain exists. There is a basic WordPress installation. There's a skeleton of stuff that is just beginning to exist. So soon it will exist. And it's kind of skirting the, yeah, I've got to be careful because of trademark issues and those sorts of things. It's skirting what I can do in terms of being true to the original Dick Smith Fun Way into Electronics and honouring the legacy of what that is without being in breach, no, I'll do resistors first, without being in breach of trademark and all of that sort of thing, not making people upset. So, what am I, cam focus? cam focus. I think that was just... Oh, Henrik says it should be an Arduino Uno oscilloscope. Right, okay. Cool. So it's a dual channel oscilloscope type thing. Nice. Yeah, I did one of these in Practical Arduino. One of the projects is an oscilloscope type thing. In fact, that might even be here. I saw it just recently. I had it out because I was looking at something. I don't even remember what. All right, so that goes there. In fact, I'm gonna, yeah, I will put this in now, but I'll just lie it down flat. So that goes in here. Yeah, for Practical Arduino, I did a an 8-channel Arduino oscilloscope and put it in a little metal enclosure and did some code in processing to display the traces. It's one of the projects in the book. These days, like back then, there was no serial plotter in Arduino IDE. So if you wanted to have a stream of values coming back and then display them on screen in a chart, like a time-based chart, you couldn't do it directly in the IDE. Now you can, but back then I did it using processing. All right, I'm just going to measure these rather than, where are we? Ohms mode. It's the lazy way out of it. What is this value? This is jumping around all over the place. It's 104K, give or take. Where is there a, oh, that one says 120K, maybe that's it. Oh, 1, 2, yeah, it is. So that's one, it's brown, red, yellow, which is 1 to 5. So 5? I can't remember. 120K. That one in there. Okay. Oh, I bent it on the wrong position. Now, get in there. Not very nice assembly. I'm kind of rushing through this because I want to get this done before the end of the stream. We're not going to be able to demonstrate it because I don't have the code up and running. So this is about 300K, just under 290K. Do we have a 290 on there? What is that one? That's 520. Oh, I'm getting strange values coming off this. Let's check this one. What is this one? This one says that it is 100 ohms. So that's the 100 ohm 1%. Okie dokie. 11 minutes. I have my timekeeper keeping me on track here. Okay, so that is the 100 ohm resistor. Yeah, and I can't really run over on second Sunday of the month because I've got to be ready for the barbecue. All right. I think I will resort to reading the color codes on this next one. I need to switch over the multimeter batteries. I've got my Unity multimeter up on the bench is connected to an external battery pack, so it's not using the single internal 9-volt battery anymore. And it runs for years and years on that battery pack. But so green, brown, yellow would make it, now what is green? Someone's got to call that green. Green, brown, yellow. So 5, brown is 2, yellow, 520K, I think that one is. So that one goes in this position here. And then what do I need? The last one I need is 12K. Yeah, I'm sure I've got a 12K somewhere.
John, do you understand cable ties asking you saying 100 ohms in parallel with fingers?
100 ohms in parallel with fingers. Oh yes, that would be the dodgy value because I'm sticking my hands across the multimeter probes.
Oh,
Yeah. me influencing the value because it's measuring me plus resistor.
Yeah, sorry, because I'm not watching, I'm just reading.
Yeah, you don't have the context. All right, now my diving into my big pack of through-hole resistors. What do I need? 12K. Is it 12K? Yes, 12K. 12, 12, 12. 12K. That's funny. 12K bag is empty. Okay, Henrik, how critical is that 12K resistor? Does it need to be actually 12K, or can it be a 10K or something else? That's a good point. Let's see. Let's see if I've got a couple around 24. No, I've got a 27K. That's no good. It'd be pretty well. Yeah, but it depends how close is close enough. I've got a 20 and a 27. If I twist those together, that's pretty close. What do you reckon? A 20K and a 27K in parallel. Does that give us about 12K? It'll be in the ballpark. Cable Ties says, I can hear Chip in the background.
I've got ones on R1 plus R2 going through my head at the moment.
The formula. Yeah, Henrik says, yes, it should be 12. All right, let's do the calculation. Parallel resistor calculator. This is how lazy I am, is I don't even bother to, to do this stuff. Look it up. Number of resistors, 2. Resistor 1, 27. Doesn't matter if it's ohms or k ohms. Second one, 20. Output equivalent, 11.49. So is 11.5K close enough? 10K and 2K in series, says Scott. Yeah, maybe that's a better way to do it. I don't want to make this PCB look too messy though. Yeah. Yeah, we could trim this and get it spot on. No, let's, I don't know. I've got no idea what that's doing in the circuit. Yeah, so, okay, so we've got a 10K, and do I have a 2K? I got a 2.4, I've got it, yes, I got a 2K. Okay, so we can achieve it. We can put a 2K and a 10K in series, but it will make the board look a little bit messy. I'm sorry, Henrik. All right, 2K out. Oh, is cable tie coming? No? Oh, I just said hello. Oh, okay. Okay. All right. Well, I don't think so. Yeah, so maybe cable tie will come today. I'm just going to lay it down there. This is a kind of dodgy construction, but what I'm going to do is lay those 2 resistors down here on the board, fold the other legs under. Just going to put it down here so that you can see it, and then I'm going to solder the pins, the leads that go through the PCB so that it is mechanically fixed in place.
Quite a while ago, Don said cam focus, but that was quite a while ago.
Yeah, I think that might have been while I was holding the board up like this. It goes out of focus, but when it's down, sitting on the bench, it's all right. Okay, so these 2 leads, somewhere around my workbench are my nice Lindstrom cutters. I haven't seen them for a couple of days. All right, now let's just solder these 2 together. In fact, I'm going to pre-clip these. Clip that one off, clip that one off, and solder those together. So hopefully, Henrik, this gives us the 12K that you need for that particular resistor. What else have we got? Time is, oops, about 3 minutes to go. 3.5. Oh, so long. All right. I want to get this all assembled apart from the through-hole headers that go onto the Arduino before the end of the stream. So what would be interesting is to connect this up to a signal generator, which I actually have right here on the bench, and plot it on the Arduino. So maybe next live stream we can do that if we have Henrik's code to run on this. And what we can do is plot the signal on my Rigol scope, plot it on this, and also maybe if I can find it, plot it on the Arduino oscilloscope that I did years and years ago for Practical Arduino. I wonder if that code even works anymore.
Cable tie can't make it today.
Oh, cable tie can't make it. That's a pity.
He says this board uses fuzzy logic.
Fuzzy logic?
The focus.
Okay, nearly done. I'm kind of rushing to get this done. So what do these buttons do, Henrik? Are these for user interface? So that you can click through menu items or something? Or is it more related to the, like directly into the circuit controlling signals? Did I miss any? No, I think I got all of the pins. All right, so we've got 4 buttons on there. These are the last things.
Referring to when it's being held above the bench,
Yeah.
but no response from Henrik.
That's okay. Hang on, I'm just going to get one of these mechanical stakes in place. This footprint is fairly loose, so when the I'll show you with this connector. You put the connector into the footprint, and the whole thing moves around quite a lot. So I want to just get this all sitting down.
It's not my code. I actually got the thing from YouTube.
Okay, Henrik got the
100% precise because the connectors are for Jones as well.
That was a bit dodgy then. I was just trying to get the connector to sit straight. No, it's still not sitting straight. Is that it? Straight enough. Okay, now I'll solder on the other parts of it. Yeah, well, the nice thing is that you've got proper connectors on here. On the one that I did, I was super dodgy. We're only dealing with the analog inputs on an Arduino anyway. They're only like 10-bit ADCs. They're not great. They're not bad. I mean, for what they are, they're actually okay. Probably better than the ADCs on a modern ESP, even though they're 2 bits lower resolution. They seem to be a lot more consistent.
Straight enough Australia.
Straight enough Australia? Yeah, solder it on upside down and we'd be right.
Peter says 10 seconds.
10 seconds. Working under pressure.
Peter's tummy's rumbling.
Yeah, we need to get some sausages on the barbecue.
I will help you get it going.
I'm actually having a bit of trouble getting the solder to stick to the connector. It's
Flux on it or something.
Yeah, it's like a plated. I'm just going to have a quick squeeze under the microscope. Oh no, it has wetted, but not consistently all the way around. It's
Henrik says he added the connectors so that you can use CNC crop clips there.
yeah,
That might be ready.
yeah. Yeah, these connectors have got, I don't know, they're like zinc plated or something, and the solder is having a little bit of trouble sticking to it. Got to get it up to temperature and get it nicely wetted before the solder will stick. And because it's actually a very big mass, these connectors are physically quite heavy. It takes a bit to get it up, yeah, to get some energy into it. Yeah, I think I might. Let's chuck some, chuck some flux on it. This is going to make it all smoky, but hopefully we'll make it work better. And I'm going to reflow these ones over here.
White Mazda pulling up.
White Mazda. Oh. Mm-hmm. We might have someone arriving for the barbecue already. Okay, thank you. Let's see. Yeah, maybe it's working. Oh, you can see all the smoke coming off it. Ah, gassing myself out with the flux. Oh, there it goes. Oh yes, that's right. I was going to reflow these ones. So, that's right. I was also going to show you a video of a KO pick and place machine doing a bit of a run because I've had a good win this week. I got the Poorest Man feeders working. Yeah, that's better. With the flux on it, they definitely worked better. So with the Poorest Man feeders, I got the machine doing one part only because I've only had one feeder set up at the time. But that's it. So that is Henrik's little oscilloscope board all assembled, apart from the OLED. Okay, so I've got to get an OLED on there as well. That's the thing to figure out for next week. Yes, already cooking, says Henrik. Okay. Yep. G'day. Mr. Barbecue is here. The benefactor of the barbecue. So what am I looking for? I'm somewhere I had pictures. Where is it? Dropbox. I am going to find a video. I'll finish up with this. Is this the one? Yep, I'll bring this up where you can see it. Okay. Input. I'm all flustered now. Here we go. Okay, so this is a video of the KO putting some parts down. I'm just going to let it run. So you can see it doing the check there. So the feeder that is, I'm going to mute that because it's kind of loud. So you can see the feeder here in operation. You can see this metal part moving backwards and forwards. That is, these metal parts are from a Yamaha CL pneumatic feeder, and it is fitted onto a 3D printed chassis. And then down under here, you can just see right at the bottom, that is the horn coming off a hobby servo. So there's a Metal Gear hobby servo sticking out the side here. And then this vertical bar is like a push bar with a couple of, what are these things called? I can't remember. There's a universal joint on each end, not a universal joint. There's a coupling on each end. So the servo is pushing the Yamaha mechanism backwards and forwards, where the pressure solenoid, like there's a normally an air solenoid that does that job. So if I run that video again, you'll see that the top of the feeder, it moves forward and then advances the tape, and then it's peeling the cover tape off with a little N20 motor at the back. And what it's doing there is putting, what are these? 100 nanofarad capacitors, I think. It's putting them down on a panel. So there are 24, yeah, I think 24 little PCBs on this panel, and it's just putting down the 100 nanofarad capacitors on those. And you can see that it's doing the, it's using the optical alignment. So it picks it up, moves it over the camera, turns the LED on, checks the alignment of the part on the nozzle, and then puts it down at its destination location. And it ran flawlessly. So I ran a couple of panels through, and it had 100% success rate on the on picking the parts. It didn't drop a single part. Every one, it aligned perfectly, and yeah, I was really happy. Got to the end of the job, reflowed it, all worked nicely. So that is quite an achievement. Since then, you can see that there are across the back of the machine here, this is the other side of it, you can see a row of Yamaha CL feeders. I've since taken all of those off. Well, technically, I asked Tommy to take them all off, and he did. So there, I've now got a mounting bracket across the back there, and I've started mounting feeders along there as well. So, right, machine working, kind of. So this was actually the first panel of a real run. So I've run test jobs on this before. Like I've put a board in there with double-sided tape on it and put parts down on the tape and just made sure that it could align everything. But this was the very first time that I ran a real panel through it, and this is a customer board, and put parts on and reflowed it and everything worked. So that's a pretty big milestone. We now have a working pick and place machine. Okay, I think it's time to wrap it up. I've got to start getting things ready. It's already well after 12.
I can hear your tummy rumbling.
My tummy was rumbling, yes. And I got to go. So, if you are in Melbourne, it's not too late to come along to the barbecue. Jump into Discord and get the address and come along and say hi and have a sausage. Thank you for coming along. Thank you, Henrik, for sending me the box of all the random bits and pieces. Those LEDs are really intriguing, the little color changing ones. And I want to try the DIY oscilloscope next week. We'll see how that goes. So Henrik, please send me the code for that in the meantime, and I will do some testing so that we can make sure that it's working in time for the stream. Okay, have a fantastic weekend and coming week, and I will see you all next week or at the barbecue in 22 minutes. Thanks. See ya.